Okay, hello all. Let us start with embedded system. Embedded system. So we'll first of all try to understand what it is. It is the combination of all the components. These components may be electrical, electronic, mechanical, and all other parts. Maybe just take an example of AC. It has just got its electronic components, mechanical components, IC in it, RAM, ROM, etc. in it. So every air conditioner is an embedded system on its own. If something is controlled through the network, then it is called as IoT. Maybe we all have, like mostly nowadays, everyone is having air conditioner in their home, but few of them get it access through their mobile as well, right? Apart from the remote of AC, we have it access through our mobile as well, just for convenience sake. So in that case, we call it an IoT device. Apart from that, we call it an embedded system. So now let us see about what is a system. It is an arrangement in which all its units assembled work together according to a set of rules. So the system is a set of rules where it has to work according to the set of rules which is predefined. Example, watch. So if one component also fails, then the watch will not work, right? So that is about system and embedded system in the sense even if one component fails, but the other components are there to support and that part of work will be done. Whereas a system, even if one component fails, then the entire system fails. So this embedded system, it is a combination of software and hardware. It is designed to perform any particular task. The task has to be completed in that particular time period. Example of this embedded system is your mobile phone, washing machine, microwave oven. All these requires hardware and software as well. Now we'll just see here embedded system is a specialized computing system that performs dedicated functions within a large system. It typically consists of hardware and software. It is designed to operate in real-time specific constraints. You all, like I was telling, real-time examples, right? Maybe your AC, even your fridge, washing machine, and all this. Embedded systems are everywhere from household applications, washing machines, microwaves, and etc. Here's an illustration of an embedded system, which is microcontroller, which is the brain of the system, sensors and actuators. We'll see in detail about what or how these sensors and actuators work. Next is software, the code that runs on the system. Next is power supply, supplies the necessary power of the embedded system. Next is communication interfaces. We'll just see the important key characteristics of embedded system. There are many key characteristics, but we are just going to focus only on three. Real-time operations. So embedded system often need to perform tasks like real-time operations. For example, airbag system in a car must detect a crash and deploy within milliseconds. Okay, so in a fraction of second, some accident might happen. So this airbag must do its duty on time within that particular millisecond. Delays are unacceptable in any embedded system because they could result in failure or safety of the issue. Of course, in during an accident, if the airbag fails to do its job, that particular millisecond of time, if there's a delay, then obviously it is of no use. It does not serve the purpose. Then resource constraint. Embedded systems are designed to have limited resources like memory, processing power, its capability, capacity, storage, all this. Because of these constraints, embedded systems are optimized for efficiency and minimal resources. They typically run on low power, cost effective hardware with just enough computing power to perform their task. Dedicated functionality. Embedded systems are designed to do one specific job or set of related tasks. For example, embedded system in a digital camera controls the process of capturing and processing images. So its software and hardware are fine and turned into performs like a task. Like its characteristics are sophisticated functionality, as we saw, real-time operation, then low manufacturing cost. Why less? Because it's designed to perform that particular task. That is why it is manufacturing cost is less in the separate system. Because as I told in examples, maybe just consider your watch, AC, washing machine, all these. It just performs that particular task alone. Maybe just consider your TV and your remote. Your remote has certain buttons, maybe volume button, on off button, numbers there. So when I just try to click on the on button, it serves only one purpose. That is, it has to turn on the TV. That's all. With that particular button, I cannot perform other tasks. I cannot perform like increasing the volume or decreasing or just trying to change the channels there. With that one particular button, no, there are like every button has its own particular action to perform. This is what we are trying to say here. Next is low power consumption, then application dependent processing, then restricted memory. All these are embedded systems characteristics. So next we'll just see about what is this modern IoT applications. So modern IoT applications we have consumer application, organizational application, industrial application, and infrastructural application. Consumer application examples are vehicle, shoes, watch, ring, fingerprint, all these things. Consumer applications. I'm speaking about IoT applications here. Next is organizational applications. It may be any organization. It may be your healthcare, your transportation, any farming fields, and all these things. Next is industrial application. It may be smart manufacturers like predictive maintenance, then tracking system, quality control, safety, distribution of material, automation, like how industries just automatically try to fill in if there is any lack of components or any lack of their products, or their product has been all distributed among the other places and all, and they have a lack and they have to refill it. So we get automatically all these things are done without manual assistance, right? That is what we told her. And infrastructure applications, maybe bridges, railway, wind farms, and all those things comes under infrastructure applications. Now we see about just see IoT applications. Like as we were discussing here, they have just mentioned two kind of applications here. One is temperature sensor, other is proximity sensor. We already discussed regarding this temperature sensor. Temperature sensor is like it just measures the temperature and tells us. So it just detects the outside temperature. Well, it maybe we just connect this temperature sensor to our fan today. Okay, just imagine just mentioning the threshold value. Maybe the temperature threshold value temperature, I'm just mentioning it as 25. So whenever my threshold value, if there's an increase in temperature, okay, so if the room temperature is 25, then my fan is going to be off. If the room temperature is 26 or 27, if it exceeds more than that particular threshold value which has been fixed, then automatically my fan will be on. I need not go on switch on at all. So this is what is IoT, connected and based on how things work. Hope you understand this. So how does it work? Based on this temperature sensor, okay, based on the threshold value which we are going to feed in. The IoT application, temperature sensors are used in smart thermostat, industrial temperature. Okay, next is proximity sensors.